Hello and welcome back to another video. In this problem, we're asked to find the exact value of each expression. So in part A, we have log base 2 of 32. And what we do to find the value is we set this equal to y, where y is going to be our answer. And then we use the relationship of the logarithm to say, okay, what does this actually mean in a standard function? And it means the base 2 to the power of whatever the log is equal to, y, is equal to 32, the value that the logarithm takes on. So log base 2 of 32 is equal to y. Therefore, 2 to the y is equal to 32. 32 is 2 to the 5th power. So if we have 2 to the y power is equal to 2 to the 5, then the exponents are equal, y equals 5. Similar thing here with b. Log base 8 of 2. This is equal to y. Or we could call it z, just to not confuse with this y. Therefore, using the same relationship that we did before, 8 to the z equals 2. Now we just have to turn these into a common base, just like we did here. 8 is equal to 2 cubed, so this is 2 to the 3 to the z, and this is equal to 2 to the 1, which is just 2. When you have 2 to the 3rd power to the z power, 1 power to the other means you multiply them, so this is 2 to the 3z is equal to 2 to the 1. And again, we have the same base, so therefore the exponents, 3z and 1, are equal. And now we just divide by 3. This cancels. We get z is equal to 1/3. So therefore, log base 2 of 32 is equal to 5, and log base 8 of 2 is equal to 1/3.